In this lecture, I'm going to explain to you the f of x terminology. So beginners, pre-calculus beginners, algebra beginners are often confused with the terminology. What is f of x? What is this? So that's something very different from the ones we've learned from the arithmetic classes or prior to this discussion. Okay, prior to algebra, prior to pre-calculus, and so on and so forth. Now, let me begin the terminology discussion or definition by giving you an example of f of x. Now, this function here, this symbol here, that's f of x, okay? That symbol here, as you can see, f of x. Okay, now don't be confused with the parenthesis and with the x inside to be multiplication. That's not multiplication. Okay, that is not multiplication. So this is not multiplication. That is simply substitution. Okay, this is simply a substitution symbol. Substitution symbol. Okay, meaning that for this part here, and we have f of x is equal to x squared plus 5x plus 3. For this x here, we are going to choose any value, any random value. For example, x is equal to 2. So now we will have f of 2 instead of f of x. Okay? And then this 2 here will just be substituted to every x that you can find on the function. So let us do this with this case. Okay, let us say our x is equal to 4. Okay, if x is equal to 4, then we will have f of 4. And evaluating that on the expression given, we will have 4 square plus 5 times 4 plus 3. And evaluating that, we have 16 plus 20 plus 3. Therefore, our f of 4 will be the value gotten from this addition. So we will have 16 plus 20, that is 36, plus 3, that is 39. That is 39. So our f of 4 means 39. Now, if it's not clear to you, okay, let us take this example again. Let us take that example again. Our f of x, as you can see, and obviously, are only having the letters x. So, lyrically, you can only see the letters x. Okay, x and x. Okay, so when you see a letter which is corresponding to the letter in there, then that is a function of that term. So in this case, our f of x, which is sometimes taken to be y, because as you can see, and as I've explained in the previous lectures, your y is the dependent values, or your y contains your dependent values, and your x contains your independent values. So y is equal to f of x, and your f of x should only be in terms of x's. So you have x squared plus 5x plus 3. no y's or no other letters aside from x. No n's, no a's, no b, etc. Okay, so that explains what the fx terminology means. Let us have another example here. Now in this example, as you can see, we have a different terminology. It's h of t. So h of t. But as you can see here, all of your expressions are only in terms of t. So we have 4.9 t squared, 10 t. Okay, so this pretty explains what a function of something, of some variables mean. In the previous example, we have literally a function of x. A function of x. Now in this case, we have a function of x a while ago. Now in this case, we have h of t, which means that your time, or t, is in the expression. It's your h, your height, for example, is taken in the expressions of t. So you use the t variable to find your h of t. So as you can see, this is somewhat related to your physics. Okay, this is h of t just means your height, and the function or the expression that defines it is given by negative 49t squared plus 10t plus 70, which is the equation for motion. And in this case, this is a projectile motion. So that's it. Your h of t is in terms of t. And the other one, let's say your v of t, which is just the velocity. Okay, this is just the velocity. Is actually expressed in terms of t also. You have t here, so it's negative 9.8 t plus 10. Now this is pretty much useful in physics. So what are we going to do with this? Let's try to graph this function x squared plus 5x plus 3 by getting the x values. So we set the x values. This is your x, and this is your y values. So let us define the x values. Let us set them. We have, let's say, I'm going to take negative 2, the same as before, 0, 1, 2. Now if you substitute your negative 2 to the x's here, then our y for negative 2 would be negative 2 squared, that's 4, plus 5 times negative 2, which is negative 10 plus 3. So we have 4 minus 10 plus 3 would be equal to negative 3. So we have negative 3 here. Okay, if it's negative 1, if your x is negative 1, that's negative 1 squared, which is 1 squared, plus 5 times negative 1, which is negative 5, plus 3, so that's negative 5 plus 4. That would be negative 1. If your x is 0, then that would be 0 squared plus 5 of 0 squared plus 3. That would only give you 3. If your x is equal to 1, that would be 1 squared is 1 plus 5 times 1, which is 5 plus 3, which is equal to 9. And if your x is 2, so 2 squared, which is 4 plus 5 times 2, which is 10, plus 3, so 10 plus 3, plus 4, that would be 17. Okay, we try to plot this. So negative 2, negative 3, negative 2, negative 3. So negative 2, negative 3. So it's here. Okay. We have negative 1, 1, and negative 1 also. So we have here, we have 0 and 3. 0 and 3. 0 and 3, it's here. We have 1 and 9. 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's here. I will not plot 2 and 17 because it's too long. Now I'm going to add another. Okay, let's say we have, I will add negative 3 and negative 4 and negative 3 to the line. So to the set of x values. So we have, if it's negative 3, then your f of x would be negative 3 squared, so that's 9, plus negative 15, so 9 minus 15, which is negative 6, plus 3, so we would have negative 3. So it would be negative 3. If it's negative 4, if x is negative 4, we have negative 4 squared, which is 16, plus 5 times negative 4, which is negative 20. So 16 minus 20 would be negative 4, plus 1 would be negative 1. So we have negative 3 and negative 3. Negative 3 and negative 3. So 1, 2, 3. It's here. It's not there. Negative 3 and negative 3. So it's here. Okay. And we have negative 4 and 1. So negative 4 and 1. So it's here. Okay. Oops, I think I made some mistake here. I think this one. Okay. We have, so let me correct that. So we have negative 3 and negative 3, so it's the same here. It's the same here. Okay. And we have defined a parabolic equation. Or we have defined a curve, a graph, which is curve. Okay. So let's start with here. And okay, so it's going to the top. So connecting all of the points, we got something like this. So we have a curve like that. This is a curve. Okay, this part is a curve. This part here should be a curve. Okay, should be a curve. Okay, and actually, if you are going to thoroughly get the graph of this one, it would look something like that. Okay, and it's symmetric in the middle. Okay, now this is the graph of this function x squared plus 5x plus 3.